We good? Okay, good morning, everybody. Glad to see you guys made it awake, early hour, to hear something about DevOps and AppSec. So let me jump right into this. Let me introduce myself. My name is Jeff Williams. Some of you may know me from some of the work I've done at OWASP. I wrote WebGoats and the Enterprise Security API and the OWASP Top 10 and a few other things. I was chair of OWASP for 8 years. And I'm also the CEO of AppSec Security, consulting company. And if any of you are smart and humble and really passionate about application security, we've got some great jobs available now. Come talk to me. And if any of you are really tired of hassling with static analysis tools, you should definitely come check out Contrast at our booth. It's definitely different, I promise. So I wanted to talk about application security as healthcare, and there's a lot of similarities there. So, if you imagine that applications are patients out there, we've got a lot of potentially sick patients out there, and we've got a small number of doctors that are experts in the field, and we've got some fancy tools for those doctors to use, things like MRI machines and tunneling electron microscopes. And those doctors are helping people, right? We're good at it. We can go in, we can help work on an application, we can find problems, and that's great. But even if we had the best doctors in the world, we wouldn't really be able to make much progress against disease. And so I want you to think about application security as a public health issue, and think more like how the World Health Organization works. How do we stamp out cross-site scripting or SQL injection? How do we stamp out that as a disease? And you need different techniques if you're going to work on the disease than you do helping patients. That's why we can't just take the things that we do for patients, code reviews and pen tests and things like architecture reviews and so on, and just scale them up, because it doesn't work. We need different techniques if we're going to tackle disease in general. So I've been following with great interest the progress that's being made in healthcare industry. Sensors are literally revolutionizing healthcare, and you may not even notice it. So there's all these different companies that are building sensors that attach to your body or go inside your body in some way. They monitor blood pressure and blood sugar levels and activity level and your diet and everything that's going on in your body, temperature and so on. In fact, there's a tiny little sensor, it's about the size of a grain of rice, that you can inject in your arm, and it'll monitor your blood sugar for you. And if you're diabetic, you can get immediate alerts on your blood sugar. You don't have to go stick your finger once a day. You don't have to go check a doctor in a hospital or anything. It just monitors it continuously and in real time. And it's a dramatic change for healthcare. In fact, I can imagine a day when we're not doing periodic checkups at the doctor the same way that we do today. That's a very reactive way of doing healthcare, right? You go to the doctor once a year, or if you're me, like once every 10 years, and you find out that you had some problem. You're discovering it way too late, right? I read that in a matter of just like a year, they're predicting that your phone is going to know that you're sick before you do, because it's going to be monitoring all this stuff on your body. Does anybody use like Fitbit or one of the sensors? There's a lot of people are starting to do this, and it's great. You get real-time information about your healthcare. So let's switch back to AppSec for a second. So our traditional techniques for doing AppSec they're failing. They're crumbling at the edges. And so, for example, static analysis tools are a great idea. I was really into that idea for a long time. But when you look at modern code, you don't have calls to request.getParameter and SQL.execute statement anymore. That code is pushed down into some framework like Spring, somewhere in the bowels of Spring, or into Hibernate on the database side. And so what is the static analysis tool really analyzing, unless it understands everything about your framework? So that they're starting to have trouble with new programming paradigms. Actually, it's really since about 2005, there hasn't been much advance there, and the frameworks have been rocketing forwards. So we have trouble with custom frameworks. We have a lot of trouble with, on the dynamic side, with custom protocols. You know, your scanner tool probably doesn't work on REST interfaces and web services, and it probably doesn't work real well on WebSockets, and you know, a whole bunch of custom protocols that we just don't have the tools to analyze. In fact, if you're dealing with that problem, you might check out JavaSnoop. This is a different way to analyze an application. But there's some real challenges here coming in the very short term. Even penetration testing is crumbling a little bit. When we go into new applications now, we're spending a good amount of time just figuring out how to get the tools to intercept the traffic and actually to do our work. So, you know, we're spending the time that we used to spend actually finding vulnerabilities, we're spending getting the tools running on the apps. And our stuff doesn't go fast enough to deal with new processes like DevOps and Agile. We've got projects that need feedback right away, and they're not getting it because our processes are too slow. So I think of it this way. I'm really proud of the work that we've done at OWASP over the last 10, 11 years that I've been involved. And we've put out some good standards, we've put out some good tools, there's a wiki and a whole community built up. But, you know, and I'm proud of the progress that we've made, but the problem is that progress pales in comparison to the development of software. It's rocketing ahead while we're, you know, kind of plugging up the foothills here, right? This doesn't work. Keep playing this forward, and it just keeps getting worse and worse. And so we need to do something to move security over into the development process. We've got to get aligned. And you'll hear a lot of people talk about, we got to push left. We got to get into the SDLC. What they really mean is we need to take our activities that we're currently doing, things like code review and pen test and scanning and static and that sort of stuff, and push it into this SDLC over here. Well, they don't care. They don't want it, and it's not compatible. So they're not really going to adopt it, and it typically doesn't work out very well. So in this talk, I want to suggest that we need to do something different. This is that scene from Apollo 13, where they just discovered that the oxygen cleaners on the spaceship aren't working, and they got to, you know, pull the ones out of the LEM and put it in the command module. And they dump all these parts on the table, and they say, we got to make this square peg fit in this round hole. And what I want to do is I want you to imagine we got a lot of stuff on the table, right? We've all got our processes, we've got our tools, we've got our techniques. We're going to look at all that stuff, and we've got to throw away everything that doesn't work at DevOps speed and portfolio scale. We've got to reimagine it to work with software, current modern software development. So let's talk about what is portfolio scale. So, you know, a number of you may have massive application portfolios. We have clients with hundreds of apps. We have clients with thousands of apps. We've got some with more than 10,000 apps. And that's a daunting task. You can't review every line of code. So, you know, what are we going to do? Here's how I define portfolio scale. What I mean is that for all of these applications, we have the right defenses for those applications, and those defenses are themselves present, correct, and used properly. Okay, so I want to get concrete about what we actually are trying to do. This is the deliverable from all of what we do in application security. If we have confidence that we've got the right defenses in place and that they're present, correct, and used properly, we're in pretty good shape. So that's what I want to, that's my target. I want to think about how do we get there. And then DevOps speed, I think of application security that happens continuously and it happens in real time. So as you're writing code, as you're building applications, you get almost immediate feedback on what's happening. That's my goal. That's what I mean by AppSec at DevOps speed and portfolio scale. So how are we going to get there? Well, let's wind this way back. One thing at a time, okay? What if I said, you know, for my application, all I really care about is clickjacking? Now that's a dumb policy, but it doesn't matter what your policy is. We'll just choose one thing and we'll see if we can make it work, right? So is my whole portfolio protected against clickjacking? Can I achieve that? Well, let's think about it. So here's a typical application stack. We've got on top, we've got some custom code up here. We've got a controller, a presentation layer, some business functions, data layer. Then down below, we've got a whole stack of stuff. We've got third-party libraries. We've probably got a framework, like Struts or Spring or something. We've got an app server, platform runtime, operating system. So what we need is we need to identify vulnerabilities in this and prove that we've got clickjacking protection across this. So where can we get data to do this experiment? Where can we pull the data that we need? When I think of a vulnerability, I think of it as not a single line of code. I think of it as a flow through the application, right? It touches frequently lots of parts of the application. So we might look at HTTP data to identify vulnerabilities. So there are a lot of scanners that do this, and some passive tools that do this, like Zap. You might look at data flow through the application. This has traditionally been the realm of static tools, but now there's IaaS tools, interactive security tools that can do this really well. You might look at control flow in the application. You might look at the libraries and frameworks to make sure that they have, that they're secure. Configuration data, and then on the back end, the connections that are going out to other systems. So this is all data that we can use to identify vulnerabilities. The question is, how are we going to get access to that data, and how are we going to use it to decide whether we have protection against clickjacking or not? So what I want to do is I want to design a clickjacking sensor that I can deploy across my portfolio, and then use that sensor to monitor. For any time a clickjacking flaw gets introduced, I want to get notified. So how can we design a sensor like that? We've got all these data sources. We need to pick which one makes most sense for detecting clickjacking problems. So what's the best defense against clickjacking? Say again? Yeah, let's look for the X-frame options header, right? We should probably have that header set on all of our applications, okay? So we're probably talking about HTTP, right? We'll get our data from HTTP. How can we get it? Well, we could scan the application, or we could put a passive sensor in place. So in this column, what is our technique here? I'm going to choose passive because I just saw Simon Bennett's talk yesterday on Zap, and they've got some awesome new features in Zap that I love. There's this Zest scripting language, which is amazing. So let's think about doing that. And I want you to think about what style of verification are you going to do? Are you going to search for negative vulnerabilities? Like, are you going to search for a misconfigured X-frame option headers, a bad pattern? Or are you going to model a positive pattern? Maybe on every page you decide that X-frame options, same origin is what you want on every page. You model positive behavior of the application and put that out there. I'm personally a huge fan of positive rules. I'm not crazy about negative signatures, right? I want you to model the positive behavior. So let's make this a positive rule. We're going to search for a positive X-frame options, and then we can choose where to deploy this sensor. You could do it in dev, you could do it in prod, you could do it in a whole bunch of different places. I think in this case that a test environment makes sense. We'll monitor our test environment, make sure that X-frame options is getting set in all those. Now, this isn't the only way to build a clickjacking sensor, obviously. There's a whole bunch of different options. I want you to choose the one that makes the most sense based on how fast it is, that's how fast you can get results back to the people that need it, how accurate it is, like is this thing going to false alarm all over the place, or is it going to give you really just exactly what you need? What feedback does it give you? Does it give you all the data that you need, like the line of code where the problem is, or all the contextual information that you need to fix the problem? How scalable is the solution? Does it require a manual step, or is it totally automated? How easy to use it is? How much does it cost? All those are factors when you choose a sensor. But you've got a lot of options here. And so if we achieve this, in an organization, a lot of organizations look kind of like this. Underneath that pile of balloons is the security group. And they're doing all the tests, right? So they're running manual tests, they're doing dynamic scans, they're doing static stuff, they're doing interactive stuff, but they're doing it on a periodic basis. And they generate a PDF file once a year, or once every 3 years for this application, right? That's not working for me anymore. I want continuous real-time monitoring for this. So if we achieve this, we deploy one sensor, we can actually move this over into CI or in test environment, and we've got a new HTTP sensor that verifies X-frame options is set to deny or same origin on every web page. Great. And the data that comes out of that sensor, we should probably collect that somewhere, right? We're going to need some kind of data warehouse where we can collect this in real time and build a real-time picture of our application portfolio for clickjacking, right? And I want you to imagine it sort of like this. Like, here's your application portfolio. Got a whole bunch of apps. Let's put the sensor in the test environment for these apps, or whatever environment you think is best, and start them running. Start them collecting data, and they'll start pushing data into your data warehouse, and then you can start to get these awesome dashboards. Like, here's a list of my applications, and for clickjacking, we've got a bunch of grades on how well they do across the whole portfolio. You're leveraging the existing test activities here, whether it's CI or actual humans doing quality testing. You're getting the clickjacking testing for free, right? Because they're exercising the application, and you're getting this great dashboard automatically. And you can drill down into this if you need and say, hey, look, we got 72% in the financials application. We can drill down and look at exactly what pages have what headers, and developers can optimize their scores. They've got a great dashboard now to improve. So that brings us to the Beastie Boys' great album, Check Your Head. I wrote a tool called Check Your Headers, which you can go to online. It's at I've hosted it at Heroku, but you can put in any URL you want, and it'll check all these different security headers and give you advice on what they should look like. Okay, so this is a powerful application. This is going to look at your public-facing web pages and give you a great readout. It's little tools like this that you can turn in, and I wrote this on a business trip. This is not a particularly complicated thing to put together, but I'll put this out here. And if anyone's interested in using this internally, I'm sure we can figure something out. But this kind of tool is a great sensor, right? And I guarantee you, if you look at some of the applications that are out there, you're going to see some weird things in your headers. I spent a little time playing around with this. And there's a lot of weird headers out there. So this is a bunch of the top internet sites, right? And they're not doing terrible. Like, there's some sites in there that are getting 6 or 7 of these things set correctly, which is actually pretty good. So, Gmail and Etsy and a few other folks, in fact, some folks that are here at the conference, are doing really well on this. They're setting X-frame options. They're setting strict transport security, setting content type options to no sniff. They're setting XSS protection, and so on. And you should be doing all of those things on your site, too. This is not hard stuff to get done. But most of the sites aren't doing this. Now, in deference to the New York financial community, I ran it on the top 140 financial sites on the internet, according to some website. And they're not doing as well. You can see a marked difference between internet folks and financials. Now, this is weird to me, right? Because forever it was the financial organizations that were leading the way with security, right? But at least as far as adopting these new headers is going, the financial community seems to be lagging behind. I don't understand that. But I think there's a lot of good things there that you should take advantage of. All right, so that's just a little thought experiment there. We've done this at a bunch of clients, worked with them to help start to transform different areas of security into continuous real-time protection that work at DevOps speed and portfolio scale. This can be real-time. So you get this before picture where you're doing an annual pen test with negative signatures, one app at a time. So you never really get a good picture of what your whole portfolio looks like, never. Right? You're only seeing one little piece of the elephant at any time. But afterwards, we can transform to continuous real-time positive verification across the whole portfolio. So you might be thinking, okay, clickjacking, big deal, right? We did one little thing, and it's not the most critical security requirement in the world, so, who cares? Great job, Jeff. Well, you can build these sensors to verify a lot, maybe all of application security. I'm not sure, but you can definitely build them to do a lot. So we're going to talk about these things, doing access control this way, checking your libraries, checking that your forms don't have CSRF problems, checking your interpreters are protected against injection, checking encryption, even checking that your app doesn't make unknown connections to God knows what on the internet. You can make sensors for all this stuff. So let me talk about a couple of those. This is, imagine you wanted to check your access control model. This is a particularly hard thing to do. Scanners are terrible at this because it's hard. It's always custom in every application. Scanners can't check access control. So if your whole security program is built around running static or running dynamic or running both of them or running God knows what, you're probably not checking access control barely at all. But it's really not that hard to check if you think about this in terms of a real-time sensor. So I spent half an hour and wrote a little tool to just pull out the authorization checks out of an application that we run at AppSec. And it's pretty easy. I can go through, I can pull out all the, in this case, there's annotations in there, so we pull them all out and we map them to the code. You could map these to URLs if you wanted to, but you can do this. And I made it so it's a SaaS tool. There are ways to do this, other types of sensors you could build for this. But I chose this, and you can deploy this in your build environment, run this every time you build your code. And you can even use that same data to generate an access control matrix from the code directly. So some of you may have an access control matrix that was written in 1972 for your application that has no bearing on what the actual code really does. Well, who cares about that? Nobody's looking at it. Or you can generate one live from your actual code, build an access control matrix, and look at it. And we might look through here, and we might say, oh, okay, this is all looks right, all looks right. In fact, on the last slide, if you look through, you can see, hey, we got these missing access control checks. What's going on? Well, you actually think about this. You're like, oh, check app status? That's actually, we don't want an access control on that. We want to be able to check the application status. Same thing with the error page and the login controller. None of those need access control, so that's good. We can verify the access control model really easily, and we can visualize it in an access control matrix. So this is great information. Not all sensors have to say, it's 100% good. Maybe it's an intelligence sensor that just gets you way down the road. Now, to test this in a pen test would take weeks with the best tools because there's so many different combinations. And you probably need to have an account that has more than $450,000 in the IRA, and the owner of the account has to be more than 65 years old in order to verify all the aspects of access control. It's really complicated to set up the test and run them, but you can verify them in the code pretty easily by building a little custom sensor, and you can work with your developers to do it. This is really getting to what I envision as security in the software development lifecycle. Like, we're actually asking the developers to build a tool to produce this and working with them to say, here's what we need in order to verify this. They can help you produce these sensors and run them at, maybe they run it in CI, and this is all feeding into their Sonar dashboard. So anybody can check this anytime and keep it up to date. Look at another one. We just added A9 to the OWASP top 10 that says, you shouldn't be running with libraries that have known vulnerabilities in them. Well, that's not the most incredible, outlandish statement in the world, but a lot of people are. And if you're not checking your libraries, you really should. I wanted to point your attention to a tool called OWASP Dependency Check. It's great. You point at a directory, it runs. It tells you whether you have any out-of-date libraries that have known vulnerabilities in it, and if you do, then you should update them. And it's super easy to run, but why not build this into your build environment or your dev environment, or put this as a sensor so that you're running this all the time? Then you get notified. If any of your libraries get out of date, bam, you got notified, you get it up to date, and it's part of the process now, right? You've got a real-time sensor analyzing your libraries. There's no real reason why everyone shouldn't be doing this. It's not complicated. You don't need a gazillion-dollar tool. You have a free tool built into your environment, and you can get a real-time dashboard across your whole portfolio without a huge investment. Let's talk about CSRF. So here's one idea for a CSRF sensor. To check CSRF, you got to check two things. Right? You got to check that all your forms, at least the state-changing forms, have a CSRF token in them, and then you got to check that the token is actually being enforced when the requests come in, right? So my idea is run in your test environment, run your test suite through Zap. So hook up Zap as a proxy, and when you do your Selenium tests, run them through Zap. Zap is pretty good at detecting CSRF tokens, and you can build a script in this new Zest language to verify it. And then you can pull the results out of Zap, out of the proxy, with the REST API. Very powerful stuff. And you can, so then you put this in place, and all of a sudden you've got a dashboard across all your applications. Hey, are we really doing CSRF on all the forms? And then you've got a plan. Then you can go start fixing this and optimizing this across your portfolio. This is another one. One of the things that I'm really passionate about is checking to make sure that your security controls are correct. So remember in that list I said you got to check that you've got the controls present, that the controls are correct, and that you've used them in all the different places that they need to be used. Well, our tools are pretty good at checking to see whether the controls are used in all the right places. Well, actually, they're not really that good. But that's what, if they were good at anything, that's what they'd be good for. But checking the correctness of your controls, they don't even try. So your tools are not verifying that you've implemented triple des correctly. They're not checking that your validation method is doing anything like real validation. They're not checking that your canonicalization method is doing actually good canonicalization. That's way too hard. But you need to check the security of your controls. So when I wrote the Enterprise Security API libraries, we did it test first. We built a huge library of test cases for the controls to prove that they were correct, because it's kind of hard to make sure that these controls actually do all the things they're supposed to do. So this is an example of a JUnit test suite where we've got tons of test cases to verify that the canonicalization all actually works. And we've got examples of double encoding and nested encoding and all kinds of crazy encoding in there to verify that we're actually doing what we said we do. And I encourage you to do that too, because you need a dashboard that says your controls are correct. I think JUnit is great for this, but this is a piece that a lot of organizations are missing, that they're not actually checking their controls are working properly. Now, injection is obviously a huge deal. A lot of the biggest flaws are injection. It's #1 in the OWASP top 10. It's a data flow problem by its nature. Injection means that untrusted data is flowing through the application and ending up in some kind of dangerous API, an interpreter, SQL, LDAP, XPath, even back into the web page, into HTML, it's getting into the browser, that's an interpreter. So for me, the right choice for building an injection sensor is to use IaaS. Now I'm biased, I've built an IaaS technology, but this is a very accurate way of doing data flow analysis. And you can see here's an example of a cookie flowing through an application and ending up in a SQL query. So you can build an IaaS sensor to detect injection flaws in an application. Very important area. And the last one is there's other data that we can gather from applications that's really powerful. It's not just about vulnerabilities, right? We want to gather security intelligence from all our applications. So can we inventory all our applications in real time? Absolutely. We can say, you know, how many lines of code they are and what frameworks they're built on. And all this information that, you know, I work with a lot of companies, and there are frequently a team of people whose job it is just to inventory all the apps. Make sure they've got a list of all the apps, and usually there's some risk ranking procedure that says, like, you know, if it's public facing and it's got financial data and it's so many lines of code and so on, then they come up with some risk rating. That's great, but we can automate a lot of that by gathering that data directly from the applications with sensors of various kinds and at various stages of the life cycle. This is all possible, and we can do it all at DevOps speed and portfolio scale if we set our minds to it. So remember my picture with all the balloons of the security team that's totally buried? Here's what I imagine this happening. Right? We roll out sensors across the various stages, and all these sensors start running in real time. Maybe we've got some things that run in the IDE and detect vulnerabilities, detect good security practices, and start feeding the warehouse. We can do a lot in CI, continuous integration. We can run static tools. We can run Selenium tests. We can do passive testing. Same in the test environment, QA environment, staging environments. Even in prod, we can run certain tests are very inexpensive. Do you want to check that your security configuration is correct in prod? Well, testing it here isn't going to help you very much because it's always different in test environment. You want to really check it in prod. That's where it absolutely matters. So you can write sensors that don't cost very much, I mean, in terms of performance or speed or anything, to detect those problems in prod and report them out to your application security data warehouse. So that's all great. Bob. I'm going to get there. Hey, stay with me. I'm building up here, right? We started with clickjacking. Now we're doing a whole bunch of stuff. Now, you're actually asking the question that this is pointed at, right? So that's all great. We got sensors, but how do you know what sensors you actually need, right? You're going to use the OWASP top 10, like, okay, that's my list of things I need to check. Or are you going to just do what your tools are currently doing because that's what the tools do? Or are you going to rely on your pen tester, like whatever happens to be in his brain that day? What are you actually going to check? This is aspect we look at lots and lots of applications every year, and this is our results from 2013 we published a global AppSec risk report, and a lot of different vendors have a chart that looks like this, right? This says the likelihood that that an application has at least one vulnerability in this category. And what I think is interesting about our data is, AppSec uses a lot of manual code review, a lot of penetration testing. So we're doing a lot of manual stuff to verify applications, and our results are different than other organizations. So the number one finding from dynamic scanning tools is error handling. That's where they see the most problems. Static companies, their results look different. Most of theirs are XSS. So that's, in ours, that would be an input validation problem here. Ours, by far, is identification and authentication. And if you add this session management problem onto that column, you can see that's the bulk of the serious problems that we find. And in fact, we've sort of broken this out so you can see the higher risk findings and the lower risk findings. And your tool may be finding a whole ton of lower risk findings because you're not prioritized right. So, maybe you want to look at what's really important to you when you set out to figure out what sensors you want to build. I'll keep track of my time here. Okay. So I want you to think about it this way. You have some expected model. And without a model, you can't really do security. There's no meaning to security if you don't have a model that you're comparing against. And we have all these different sources of requirements that we, together, we sort of mush them up and say, well, that's sort of our model is we've got a coding guideline and we've got some security requirements and we've got a threat model. Maybe we do abuse cases. Maybe we got policy or external regulations, or maybe we got some standards out there. But we end up with this mishmash of stuff that's all, this is what we expect. We have to do this. But it's not really very well integrated, right? It's spotty. And I want you to consider that, so what we want to do is once we have that model, then we want to check, like, how well are we doing against that model? And that's going to be our measure of security. And we do all these things to verify the model, but actually, they're really kind of spotty too. They're not aligned with the expected model frequently. We just have a pen tester come in and do a pen test. Well, he doesn't know about all that other stuff. So he does a bunch of tests, whatever he's good at, and gets some results. And I want you to consider what happens when you really put these together, right? You get these mismatches. So you've got a bunch of important stuff that's not being tested. Those are all risks by definition, right? I don't know. It's a risk. I don't know if it's true or false, but we got to check that. On the other side, we're testing a lot of stuff that doesn't need testing. I've seen scanners run for hours running SQL injection tests against an application that does not use SQL. Why? I mean, that's a lot of, and pen testers too. Why are we doing that? So we need to get alignment between our expected model and what we're actually measuring. And at the end of the day, you get results that look like this. You don't have the expected model. You don't really know what the tester tested. You just get a pile of findings in a PDF report. And you're not really getting very much assurance. We're throwing away 95% of the real value from the pen test is the work to figure out this stuff. What are we supposed to be testing? Like, all that work is lost because it's not captured in the report anywhere. We're losing that. And so we really, at the end of the day, I don't think we have a very good idea of whether we're secure or not for most applications. So what I want you to think about is, can you get alignment? And this is right on the assurance argument path, is how do you get alignment between what you actually care about and the things that you're actually measuring? And I suggest that you can break it down like this. So you have business concerns. Those can break down into defense strategies, like how are you going to protect to make sure that those business concerns don't manifest. You can break down the defense strategies into actual defenses, like products and libraries and tools and whatever your approach is. And then you have sensors to verify that each of those defenses is, as I said a bunch of times, present. So we got our libraries are present, up to date, that they're correct, and that they're used properly in all the places they need to be used. This is how you build up assurance. And actually, I think the way it works in most organizations is you probably start at the bottom and start measuring a bunch of stuff with sensors, and then start to build that picture of your enterprise. Start to build a real picture of security within your enterprise, and realize, like, hey, you know what? We're missing HTTP parameter pollution. We need a sensor for that. And somebody might ask, why? And I said, well, because that would undermine the integrity of our data. We can, it's a really authentication problem when you get down to it. And you map that up to a security control. But now we're starting to iterate on the expected model, right? We're trying to get our expected model straight. Because once we get it straight, it's actually not that hard to verify. You can put sensors in place to verify this stuff in real time, but you've got to get the story straight first. So that's what this is about. I really want organizations to change the way they're doing application security a little bit. I imagine models like this, and I'm working towards this with a number of clients, is that we're deploying sensors into the application portfolio. They are measuring that portfolio against some model of what's expected. Then we're getting data back from those sensors in real time. So imagine dashboards across a broad array of security. Then there's a team that's looking at that data, right? These are the folks that, maybe they used to be doing the individual pen tests. Maybe they're, architects. These are the folks that are, charged with understanding security. They're looking at new threats, new business priorities, and maybe they tweak the model a little bit. They say, hey, you know what? We need to be worried about, two-factor authentication, or some other new interesting thing. Maybe they hear about something at the conference here, some new kind of attack. And they say, you know what, we got to be worried about that. That needs to be part of our expected model. And they say, we're going to deploy a new sensor. And so they work with some developers, they build a new sensor, and they deploy it into their infrastructure. Maybe they put it out into their continuous integration environment as part of their build process. Maybe they put it into their test environment. Maybe they put it in prod. I don't know. They deploy a sensor, and then they start measuring. And by a matter of days, they can have a pretty well-developed sense of how they're doing against that new threat. What do you guys do if like a few weeks ago, Spring 2 vulnerability it's in the library? How long do you think it's going to take for most organizations to find all the applications that are using Spring 2 and get off that vulnerable version? If they're using a pen test or one of these periodic methodologies, it could take years before they find out that they're using a vulnerable library. They should know that right away, and we can do it. It's really not as hard as we're making it out. So let's get that real-time notification. Let's get these people a model of what exists in reality, and let's iterate. And that's really where security comes from, is from that iteration. It's builders and breakers looking at the expected model, tweaking it, deploying sensors, getting real data, and tweaking it. And we can drive continuous improvement with this cycle. This is the virtuous cycle that gets us to actually the goal that I set out at the beginning of the talk, which was application security at DevOps speed and portfolio scale. So how do you get started here? I really think the best way to get started is to just build a sensor. Grab Zap, grab dependency check, grab Eclipse and write a little sensor and deploy it. And maybe you need help from developers to build it right, but get it out there, deploy it, and start building an initial dashboard. Gather some data. You can do it in Excel. A lot of the simple dashboards are just a bunch of data, and gather it on a periodic basis and put it together. And then start adding. pick another thing, and pick another thing, until you get to the point where you're like, wow, I think we've really got a pretty good assurance argument here. We've covered all our business concerns, we've got our defenses, and we're verifying them in real time. This, to me, I think is the path to improvement. Yeah. So you mean that the running the sensor is a cost on the infrastructure, like its performance or something? Sure. Yeah, so the business case for this, I think, is ridiculously strong. Because with this approach, you build a sensor once, and you get payback forever. And these sensors are not complicated. So let me talk about how I think the roles of some of these folks change a little bit. So you've got, this guy was doing pen tests, expensive pen tests, to verify things like HTTP parameter pollution and CSRF and cross-site scripting and so on. I know people whose full-time job is cross-site scripting testing. That's all they do, is they're the sensor. And they're super expensive, and frankly, they're not very good at it. And we can replace that with a sensor that does the job automatically and continuously forever, for better. We can make this work much more inexpensively than the current approaches are. So yeah, there's some performance costs, like your test environment is going to run a pinch lower, maybe your builds are going to be a pinch lower, but it's totally worth it, because the costs massively outweigh the cost of doing this the old-fashioned way. I mean, how many of you have spent time eliminating false positives from the output of some tool? Well, I mean, it's a huge amount of work, right? We can optimize that. So, I think you can get there this way, is start building tools and start building out the infrastructure for this. There is some infrastructure required. Eventually, after you've got 2 or 3 sensors, you're going to need to be pushing those reports to something, right? It can't just be a directory. I mean, it could be a directory of files, but you're going to want it to be like a web service where you're posting stuff. And there are tools out there that can do that. This is an area where we really need some folks to step in and build some kind of AppSec data warehouse that can dedupe all these findings and handle them. Yeah, in the back. So App Sensor is really much more about detecting intrusions at runtime, and certainly not allowing them to happen, but also reporting back to you that there was an intrusion. It's tangentially related to what I'm talking about, but I'm using sensor in a much different sense. I'm using a sensor that you attach to your development organization, as opposed to a sensor that you attach to your running application in prod to detect intrusions. I'm really after detecting vulnerabilities, not intrusions, because to me, that's really what you want to detect, right? You want to get the vulnerabilities out so that the intrusions fail. Yeah. Yeah. It's a little bit different. I mean, there may be some things from App Sensor that we could use to generate sensors for this, but detecting attacks is not the same as detecting vulnerabilities. Okay? Detecting attack, you might look for something like, or 1 equals 1, or various incantations of SQL, right? Detecting vulnerabilities, you're looking for a pattern, a data flow pattern through the code. Okay? So it's a different kind of detection. So let me do my last slide, then I'll take a whole lot of questions, okay? So, and we've got a little bit of time left, so that's great. So, I see us, most of the industry is relatively here. Like we're trying to do some kind of compliance exercise. We run some tool, we're trying to meet somebody else's requirements. I want to move us up a notch, right? I'm trying to get us up to the point where we're actually monitoring application security. This means that, we're instrumented, we're monitoring everything. It's just getting good data. That is the platform that we need to move farther, right? We can do AppSec strategy if we do this. Right now we can't, because without visibility into what our portfolio is doing, which we don't have right now, we've got these little pinhole visibility into our portfolio. Right? Without that visibility, we can't really be strategic. We're fixing one app at a time, down here, not doing strategic portfolio fixes. And eventually we can optimize, and ideally, I would love to get to a point where application security actually is a business driver. That people are doing AppSec because it's good for business. And that's when we've really, I think, fully integrated ourselves into software development as a discipline. That's when we achieve that push left, that continuous application security goal that I laid out. And if you get a chance, check out David Rice's talk from OWASP conference a few years ago, where he talks about pollution and how the green industry changed. He talks about getting to the point where application security is a top-line concern, not just an end-of-pipe regulation kind of concern. It's very interesting, probably the best talk in AppSec that I know of. At the end of the day, we have to do something different. We will never improve AppSec. We'll never get to that public health view of application security where we're stamping out diseases if we just keep doing what everybody else is doing. That can't be the goal. It can't be the model for AppSec. So with that, thank you, and I'd love to take your questions. So yeah, Bob. Yeah. Oh, that'd be great. You know I'm a big fan of software labels. Yeah, you can capture that stuff, and assurance should be public. It's not at all now. That's a different talk, though. Yeah, so this process. Yeah, this needs to be real time, right? You should have a group that's out monitoring for this and bringing it in and translating it into your expected model. Exactly right. Yeah. Yeah, here. Yeah. Well, it's always going to be harder in an organization that's not standardized on certain technologies and platforms, and you don't have everything building in one Jenkins server essentially. But you can put out requirements, and you can say, hey, developers, you need to produce evidence that you're protecting against CSRF or HPP or whatever, and define the deliverable for them. Developers are actually really good at building stuff if you tell them exactly what you want. And they can build the sensors and generate the evidence that you need. And it's probably good to go double check their sensors. But once you get that done, after that, then you've got assurance on that app forever. So it can scale in a distributed way as well as a centralized way. But there's no question it's harder in a decentralized organization. Yeah. It's a good question. I would love to see that. So, I think I mentioned ZAP before and Zest. Their goal is to try to create a new way of defining a sensor for that kind of vulnerability. I think ASVS is probably the closest thing. There's an OWASP application security verification standard that details out a set of positive requirements for apps, and it's a good start towards a standard that you could then say, okay, I need a sensor for everything in ASVS. But really, I think it's best if you think about your own sensors and what you're trying to verify and build it out locally. I'd love to see a project around, let's do this. Let's build sensors for a whole bunch of common stuff. And I think SCAP's a good analogy, actually. Right. It's all about CWE. Sorry. Yeah. Oh, yeah, sure. So the Heroku app was pretty fun. You see a lot of weird stuff in the headers. A lot of people put little custom weird headers. Etsy, for instance, says, is coding your craft? It's like X hire, X recruiting header. It says code your craft. There's a lot of fun stuff in the headers, but yeah, please check it out. Let me know if I blew it on any of these recommendations, by the way. I'd love to get feedback. Anything else? Yeah. Sure. To me, XSS is a data flow problem. So you probably want an engine that can do really good data flow analysis. To me, there's two games in town. There's static analysis, which is kind of noisy, but it's been around for a bunch of years. And there's IaaS. And IaaS sensors are pretty new, but they do data flow analysis really well. So to me, I choose IaaS tool and deploy it on my app servers and let it watch them run. And I got good cross-site scripting sensor. Yeah. It's really up to you. One thing you might do is you might have a positive model for detecting XSS rather than a negative model. Right? Static analysis tools implement a negative model. They model the bad behavior. Does untrusted data make it into the HTML page? But maybe you want to model your good practices. So you build a static analysis tool that says, every time we get a parameter from HTTP, we call asapi.validator, and we validate it. And then every time we write something to the HTML page, we call asapi.encoder and call the appropriate encoder. You build a sensor to verify the positive model, and you won't get all the false positives, right? So that's a better sensor. It's positive. Any last questions? All right, thank you all very much. Thanks for coming to OWASP.